Alright, so today we're going to be adding and subtracting fractions. Alright? So far with fractions, we've compared and ordered. We worked with equivalent and simplifying, right? So after this, we're going to have our first quiz on Tuesday. Alright? Have our first quiz on Tuesday. So that means Monday will be a review day of everything we've done. Okay, so the next 2 days are just going to be over adding and subtracting. Capiche? Alright.
What does that mean?
So, you guys have added before, right? We've seen addition. Basic addition. 5 plus 5. What does 5 plus 5 equal? 10. Alright? Pretty simple. But now what we're going to do is we're going to add stuff to the bottom. The 5 is going to what? Yes, you should be writing this. Wherever I write, you should probably write. The 5 is in one part of the fraction. What do we call that? Keisha? The numerator. So we need a denominator. Alright? Oh, I should have picked that up. 25. Sorry if you wrote this, I apologize. 5 plus 4 is 9. Well, I'm going to show you something right here. What is it? This is a good fraction problem. This is done correctly. What do you notice? What's true about what's going on? What do you see some similarities between the fractions? The denominator is the same, right? Does the denominator ever change?
No.
What changed?
The numerator.
The numerator. We did 5 plus 4, we get 9. Why don't we do, did we do 7 plus 7?
No.
Why?
Because they're the same.
Because it's the same, it can't change. I love this. Pizza. I love pizza so much. I want to use it all the time.
Pizza and fries.
Okay? Here's my pizza. Alright, how many slices does that pizza have?
8.
8. Alright? So, say we're at a pizza party. Alright? And Keisha and Shelby are sharing a pizza. Okay?
Oh. Doesn't it say not smell due to chemicals?
Probably. What do you do?
Mr. Boyd had those huge markers there.
I need some markers.
You take the cap off.
I need to go buy some.
Those were amazing.
Ew.
It's getting tough to chew.
I hope this is okay for the board.
What is it?
It is, you just have to get it off the, not the
Good. That is not good.
It's like permanent.
What? No, it's not. It's for overhead sheets.
Oh, hey.
Well, I can't use the blue. This is
No,
all
I
on.
just use spray.
Use me. In fact, look at it just all dissipate. Oh, now my board is blue.
It's prettier that way.
Okay, so I'm not using blue. Ah, that's poopy. Alright. So, how many slices total?
8.
8. Okay, I got 2 people each. I got Shelby and I got Keisha. Okay? So, this represents Shelby. This represents Keisha. Okay? Well, Shelby went first. She took 3 slices. Whoa. Overall. Right? So where would I put the 3? Over the 8 for Shelby, right? There goes the 3. Well, Keisha, she ate 4 pieces.
Whoa.
She just loves her pizza. Good. So how many pizzas did she eat? How many slices? 4. So I put 4 right here. How many pieces were eaten? Well, we got to add them, right?
Yes, sir.
7 out of how many were 8?
8.
That's why. That's the best way to describe fractions. Does that make sense?
Yes.
The slices never changed. There was 8 total slices. The only thing that changed were the number of pizza slices eaten. So that's why the numerator is the only one that changes. The denominator doesn't. Okay, so I want you guys to do these problems for me right here. Let's do 11 sixteenths plus 14 sixteenths. 3 43rds plus 19 43rds. And 22 100ths plus
30.
56 100ths. Okay, go ahead and add those. What do we get?
25, 68, 42, 43, 70.
So, Ben, Fagan, what'd you get for your first one?
25, 16.
Good. Shelby, what'd you get for the second one?
22 43rds.
Good. Patrice, what'd you get for the last one?
78.
Good. Now, take a look at those fractions. Are those all in lowest terms?
Yeah.
What about the first one? Is the first one in simplest terms?
No.
The first one is it?
Shouldn't be. Or is it?
Can you simplify it? Can you take a number out of either? What?
Yeah.
Do you think they share a factor besides 1?
No.
Yeah.
What factor? Like
4.
4 goes into 25?
No.
Oh, wait, no.
Okay. So the best way to do it would be this. Okay, just to check. What could we break 25 down into? 5 and 5. Put 5 times 5. What breaks it down 16 into? 4 and 4, and that goes down into 2 and 2. Okay, 2 times 2 times 2 times 2. Well, or do these have any buddies? No. So this is good. That's in simplest form. Okay? What about this guy? Well, let's test her out. 22 and 43. What can I divide? Give me 2 fractions of 22. 2 and 11. Are those prime? So it's 2 times 11. 43. 43 is prime, right? So it's 1 times 43, or just 43. Do they have any factors in common? No, that one's good. Uh-oh, 78 and 100.
No.
Yeah.
Yeah.
78 can be divided by what?
4.
2.
4.
2 times 1 gives us 78. 39. 39 and 2. Could break 39 down? You bet. What goes into 39? 3 and 13. So it's 2 times 3 times 13. 100 can be broken down into what? 5 and 20, or 10 and 10. And then those can be broken down into 2 and 5. 2 and 5, I get 2 times 2 times 5 times 5. Is there any buddies there? 2, right? This guy and this guy, so how many times do I write it? So I can divide both of this by 2. That gives us 39/50. Okay? So when you add, I want you to do simplest form. Okay? When you add, I want you to do simplest form. Okay? So what have you noticed about the situations we've had here? What's true?
All the denominators are the same.
Yeah, so that was nice. What? All the denominators are the same. What if you had this though?
And look,
Gotta find
We gotta have a
least common multiple.
least common denominator. Okay? You can't, because this is 20 slices.
yeah,
This is 5 slices.
it's then 5 to
But if it's the two same pizzas, they're the same size, does that mean, that doesn't work.
12. So then why would you do it from the top?
Huh?
Why wouldn't you just switch? Like, if the denominators are the same, over here the numerators are the same.
So you're talking about right here?
Yeah.
No.
Why can't you just do that?
Because remember, this is the total amount of slices. Okay, if I have 2 pizzas,
Yeah.
oh my goodness.
20 slices is a lot. Wait, that's probably a large pizza.
There's 5 slices. There's
Well, we're cutting.
8, 10, 12, 14, 16, 17, 18, 20, 20.
Holy crap, look at them slices.
When you add 20 and 5, is that really 25? Are they all the same size? They have to be the same size.
Okay.
That's why. Okay? So we need to find the least common denominator. So how do we find the least common denominator? What do we use?
Factor tree.
Factor trees. I have 5 and I have 20. Well, 5's prime, right? So we just write 5. What can I break 20 down into? 2 and 10, or 4 and 5? So here's 4, here's 5. 5's prime. Can I break down 4, Tyson? What? To what? Louder!
2 and 2.
2 and 2. So what's my prime factorization? 2 squared times
5.
5. Well, remember, we take the larger of the number. Well, who's the largest 2?
That one.
2 squared. So I do 2 squared. Who's the largest 5? 5. Is there any more? No, so I multiply it out. What's 2 squared? 4 times 5 is 20. So my new fractions are going to be 20. How do I get 5 to be 20, Caleb? Times it by 4. So what I multiply by the bottom, I have to do to the 4 times 1. Well, how do I get 20 to be 20? Times 1. What's 1 times 1?
Come on. Come on now.
Now, who do I add? The numerators or the denominators?
Denominator.
The numerators. I have 5 20ths. Can I simplify?
Yes, you can.
Okay. What's the greatest common factor?
Greatest common factor is 4.
20.
Well, here, go back to this. We've already done this part, right? I have 5 and 20. Don't I already have factor trees right here?
Yeah.
Yes.
What's the greatest factor they have in common?
5.
So what can I divide these both by?
5.
So I get,
1 and 4. 1 and 4.
okay?
Get there.
Any questions? Any questions? Same thing goes for subtraction. Okay? You have to have a common denominator. Okay, same thing goes for subtraction. You have to have a common denominator. Alright? Any questions?
Yep.
Let's try one on your own. Here we go. Ready? Let's do 3/8 plus 5/12. See if you can do that problem. 3/8 plus 5/12.